Good morning, everybody. My name is Gonzalo Tampier from Universidad Austral de Chile. I will be in charge of this session. And our first presentation is given by Professor Young Ringwood from the Center of Ocean Energy Research from Maynooth University. And his presentation is about the center activities and projects. So, John, please go ahead.
Thanks, Gonzalo. So this is a very light presentation, as befits 9 o'clock in the morning. So not too challenging, no equations, plenty of pictures. And I think we have some time for questions afterwards, so please feel free to explore any issues that are not clear from the presentation. So first of all, let me just clarify where Maynooth is. I guess most people here probably are not too familiar with Irish geography. So the main city of Ireland is Dublin. It's here. So Maynooth is just about 20 kilometres to the west of Dublin, and it's a university town. And our university is about 200 years old. It started life as a seminary to train priests. The reason it was set up is quite interesting, but it's probably more for a story over a few beers rather than a 9 o'clock in the morning session. And this is one of the buildings that houses the Centre for Ocean Energy Research. And the campus broadly divides into two parts. There's a sort of an old part, which is this one here, and the new part, which is on the other side of a main road. But it sort of works. We have around about, I think, 15,000 students, so it's a relatively small university. First of all, just to kick off, and you may have seen something like this slide on Monday, but just to clarify that, we're not always just trying to generate utility-scale electricity. There are some other niche applications, not all of which I've detailed here, but a number of devices, including this one here, which is called the McCabe wave pump, was designed specifically to produce potable water, and a number of others as well. There is a device like this from another company that unfortunately has fallen over, called Resolute Marine, a US company, and that was designed again specifically for potable water production. The other application that we're looking at the moment, so we look at all of these applications, but we're also looking at powering data buoys, and this seems like a very natural application because these data buoys are out in the ocean, they're moving around, so you might as well harness their power. And this is the buoy from Embarrai in California. And in fact, interestingly, they made it big enough to definitely generate enough power to power the sensors that they want, but then they found that actually they had way more power than what they needed. So now they're looking at applications for recharging autonomous underwater vehicles. I guess we've seen some presentations about oscillating water columns. They have the nice advantage that all the power takeoff is clear of the water, and that there's a natural rectification that usually happens in the turbine itself. So that's quite popular, and there have been some implementations around the world. I mean, one of the early ones was on the island of Iona in Scotland, also one on the Pico Islands in the Azores. And there is also currently a generating plant in Matricu, which is in the north of Spain, and that generates into the grid. It almost looks like a trail of disaster because the only one that's actually existing at the moment is this one. All the other companies associated with these devices, Aquamarine Power, Wavebob, and the McCabe wave pump, all those companies now at this stage are gone. So it's a very volatile industrial landscape, and thankfully there are new players that come along, but I think the whole industry needs a good success story to attract renewed enthusiasm and investment into the area. So the Centre for Ocean Energy Research is a multidisciplinary centre. I guess nearly everyone that works here that works in either wave energy or marine renewable energy of some sort appreciates that there are a wide range of disciplines. So there's hydrodynamics, there's electronics, there's electrics, there's mechanical engineering, and then all the supply chain that's associated with deployment, recovery, and maintenance. So we have a range of different sorts of people associated with those different disciplines. So typically, mathematical, engineering, hydrodynamic modelling, and simulation. Most of the focus of the Centre for Ocean Energy Research revolves around control design, estimator design to design systems that are able to estimate variables that are important but we can't measure directly, and also forecasting, because for a number of applications, particularly for control design, we need to see ahead to be able to optimally control the device. And that, I guess, reflects my own background, because I'm originally an electrical engineer, and then I did a PhD in control. It was quite a few years before I fell into wave energy, but that background, I guess, is still the cornerstone of what my interests are. We've lots of industrial partnerships, and that provides a route for large-scale experimental testing. So we've had partnerships with quite a few of the big companies like OPT in the US, Motion in Scotland, COER Power in Sweden, and there's another Swedish company, Ocean Harvesting, we're involved with as well. So that provides a good outlet for us in terms of experimental testing at high scale, but also it's very important for us in terms of the problem definition. So they help us to understand what the real issues are. I mean, we have our own, I guess, ideas that we like to pursue, but it's also important to be connected with the real world, and that's what our industrial partnerships help to do. We are, unlike the Moore Lab in Torino, who have their own devices, we are largely device agnostic. We don't have our own particular device. And that's good and it's bad. It's good in the sense that it allows us to work on a lot of different devices, and there are no issues to do with conflicts of interest with intellectual property. I mean, even working with different companies, you have to be careful about signing non-disclosure agreements and protecting each company's individual intellectual property. But it allows us to work on a whole variety of different devices. Now, that comes with a challenge, because a lot of the things that we learn about one device cannot be easily transported to another device. But I enjoy the variety. In terms of testing, then, we've sort of high-fidelity numerical models, such as CFD models and SPH, smooth particle hydrodynamic models, and then models of various other levels of fidelity that are used for simulation, power production assessment, control design, simulation, etc. We have our own hardware-in-the-loop systems. That's a rotational system to hardware simulate a flap. We have a translational system as well to simulate a heaving point absorber. And we also have another system that we developed only in the last year, which was funded by the International Federation of Automatic Control. And it's a tank only of about this long here, but we managed to implement real-time control in it, and it's designed as a demonstrator to demonstrate real-time control. And actually, you can see it physically happening, and you can make measurements that show the power improvement as a result of using real-time control. The next level then is tank testing. So we tank test in a variety of locations. We don't have our own tank. We have some tanks that are not too far away from us in Ireland. There's one in Dundalk Institute of Technology, which we use, which is about 100 kilometres away. There's a whole set of tanks in Cork, which is about 250 kilometres away, and also some tanks in Belfast, which are, I guess, about 140 kilometres away. So there are plenty of tanks in our locale. And they're really, I mean, Ireland's a small place, so there really doesn't make sense to have so many tanks in so many locations, because they are capital-intensive facilities for sure. But there are also European programs that allow us to test in other countries. If you're familiar with the European Union, you'll know that one of its principles is the idea of cross-border collaboration, mobility, and information exchange. So they had a program that they've had two different versions of, so Marinet 1 and Marinet 2, that have extended over, I think, 6 years, that provide funding to test in somebody else's tank, but it's in somebody else's country. And a lot of the testing that we've done is in Aalborg University using this rig here. So we use the sort of prototype wave energy device that they have there, which is a leg of the Wavestar device, which was a Danish device. But we've also tested in France, in Scotland, and a number of other locations as well. And then I guess the other, as I mentioned, the other testing possibility is with our industrial partners at large scale. I'm not going to go through everybody here, but just to mention the different categories of people that we have that sort of make the whole thing work. I mean, we have relatively few staff at the top. Importantly, we have a lab manager that's able to deal with a lot of administration and bureaucracy, which shields the rest of us from that. And then we have this special category of what I call honorary research fellows. And this is something that's unique to our centre. It's not a university thing necessarily, but it does have the imprimatur of the university. And we don't pay these people, but these are people who at some stage spent some time in the centre and they still stay connected with the centre. And it's no accident that Damien appears here, right, in living colour, and Nicholas as well. So they're both Argentinian. Nicholas is now in the Politecnico de Torino. Christian is back in Germany. Yera is in the Basque Country. Tom is in Ireland, and Bingyon is back in China. So in spite of the fact that they're spread to the four winds, they still remain very closely connected with the centre. They're involved in joint PhD supervision and various other things. So we're delighted that they are interested to still be connected with us, and we hope to be connected with them for a long time in the future, and indeed to add to our number of honorary research fellows. Then, as usual, we have a range of postdocs and PhD students. And we have two associated PhD students. They're actually working on biomedical engineering, which is another of my interests, but they sort of hang around with the group. And there are, interestingly, certain common problems in wave energy and biomedical engineering, which might not be obvious. Every year we take a bunch of interns. So at the moment we have Jack from the UK and Markel from the Basque Country. And we usually take, it's a varying number, but we will probably take another 3 to 4 this year. And we already have commitments to 2 more at the moment. So just to run through a range of current projects, I guess what's sort of interesting about these is where the funding comes from, who's interested in them, and who our partnerships are with, and also what the sort of range of technical foci are. So they're not in any particular order, but this first project is controlled co-design of heterogeneous arrays of wave energy converters, and this is a very challenging controlled co-design problem. So you'll have seen Damien talking about controlled co-design yesterday. And controlled co-design, the philosophy says that you design the overall system with the control system in place, because the actual optimal design is sensitive to the control system as well. What this one tries to do is it optimizes a number of things: the array layout, but also each individual device geometry as well. So it's quite a computationally heavy problem, and it needs a level of simplification both in terms of the hydrodynamic models that we use and also in terms of the control strategy that we use, because we have to do multiple iterations of nested optimization loops. So that's in partnership with Queen's University Belfast and Iowa State. It's funded by the NSF in the US, the Department for the Economy in North of Ireland, and Science Foundation Ireland in the Republic of Ireland. And we have 1.5 postdocs. Well, you might say, well, what does a half a postdoc look like? But it's a full person for half the time. Right? And that's total project funding is around about $1 million US. This is a much, much smaller project, but it's actually got a lot more partners, which is sort of interesting. It's funded by the Marine Institute, and it's a Marine Institute Owen Sweeney scholarship. Owen Sweeney was a prime mover in Ireland in terms of wave energy, and these scholarships were set up in his legacy. So this is in partnership with, unfortunately, Resolute Marine are gone now, a US wave energy company. In Barry, the Monterey Bay Aquarium Research Institute that I mentioned in relation to, they have a data buoy that they've deployed. And one of the interesting things about their data buoy is it's, if you talk to Andy Hamilton, he says it's plug and play. So basically, they have a communication with the data buoy, which allows people like us even to download controllers, optimal controllers, onto their device and get it to work in real time, which is a fantastic facility. Then we have TechWorks Marine, which is an Irish company that deploy data buoys. Plocan is a test site in the Canary Islands, and they're natural partners of the Marine Institute, who are also partners, of course. And then the Polytechnic Catalonia have become also collaborators, and we have another few collaborators that are added on now as well. So it's quite an unwieldy project in terms of the number of collaborators, but the total funding is actually quite low. And it's one PhD student, and Ian, the PhD student, manages all these collaborations very well. So that's certainly one of his talents. We have an interesting project that started recently. So we have a visiting PhD student from Tsinghua University in Beijing in China. And this is about control co-design, but it's not about designing controllers. It's about evaluating the performance of controllers, which is actually what we need for control co-design. And the control evaluation method that we have is very fast. So it suits projects like this that have a lot of computation to be done in terms of finding out what the effective control is on the overall design, rather than trying to implement it in real time. So that's quite an interesting one, and it feeds a number of our control co-design projects. This is Sea Change, is a project that started last year. Just at the end of last year. It's sort of a major national project for us, funded by Science Foundation Ireland, and that's in partnership with the University of Illinois, who come in on the control co-design side. NREL in the USA, that's the National Renewable Energy Laboratory. Danish Technological University, Core Power Ocean, who are a wave energy company. Another Swedish wave energy company, Ocean Harvesting, and Motion, who are a Scottish wave energy company. So it's great to have a mixture of academic partners and industrial partners on this. And that's a 5-year project, which when we have finished recruiting, we'll have 1 postdoc and 4 PhD students. The cyclorotor project is really an interesting one. So we just finished a project which was funded by the European Union with 9 other partners that ran for 3 years. And cyclorotors are quite interesting because they don't have this issue of reciprocating motion. They actually rotate in a single direction using lift forces instead of diffraction and buoyancy forces. And we got some very interesting results from that. And on the back of that, one of our postdocs that was working on that, Andre, he applied for funding to Science Foundation Ireland, and they have now funded that project for another 4 years, which will allow him to recruit another PhD student. So it's really nice to be able to continue on that work. There is also a national research centre that started off originally as just on marine renewable energy in Ireland in 2012. But now it's broadened out to marine energy and climate. And it contains over 200 researchers spread across 11 institutions, and there are somewhere between 44 and 50 industry partners. So it's funded in 3 parts. It's funded a third by Science Foundation Ireland, a third by industry, and a third by European Union research grants. So at our centre, we have 2 PhD students that are working on oscillating water control, column control, and the grid integration of wave energy. And those PhDs are this one is actually just finishing up, and this one will be finished next year. And we've had about, I guess, €500,000 in funding from that. And it's a really nice centre because it allows us to collaborate closely with a lot of other centres in Ireland. This is a project which I'm not directly in charge of. It's one of the other academics in the group. But this is an interesting project which looks at the complementarity and possibilities for cooperation on a hybrid platform between wind and wave. I mean, one of the difficulties that we'll have seen in some of the presentations yesterday, particularly when you see some of the wind platforms, you get a lot of pitch motion, which causes cycling of the pitch control mechanism, and that'll wear out the pitch control mechanism prematurely. So one of the things that we think we can do is we can add on some wave actuation. So, for example, this is the floating power plant platform from Denmark, which are one of our partners in this project. And they have some flaps that are underneath here, which can allow you to affect the pitch motion of the platform. And the idea really is that we should be able to do two things with these wave actuators. One is to harness energy, but the other is to stabilize the platform. So there's a possibility that we can get two benefits out of it. But we have to be a little bit careful about what actuators we use and how we use them, and what we establish as the control objective, and whether it's stabilization and or energy harvesting, or how we balance off those two requirements. Yeah, this is another tripartite project between the US, the north of Ireland, and the south of Ireland. Again, it's funded by the National Science Foundation USA, the Department for Economy in the north, and Science Foundation Ireland, in partnership with the University of Michigan and Virginia Tech in the USA, Queen's University in Belfast, and ourselves. There's two people at COER, and in fact our postdoc on this is sitting in the audience there. That's Pedro, and we've just recruited a PhD student who's arriving next week. So that's a very exciting project for us, because it's a very novel power takeoff based on mechanical motion rectification, but it actually allows us some very interesting control freedom that we mightn't have with a more conventional power takeoff system. And then about a year ago, we sort of discovered that tidal barrage optimization could be done using wave energy control techniques, because in fact if you look at the harmonic oscillation in tide, it's very similar to harmonic wave oscillation. And in fact some of the procedures and protocols in tidal barrage optimization are not that different, and they have the equivalences in the wave energy world. So that's an interesting one. It's funded by Maynooth University as a partner in this Centre for Research Training in Data Analytics, funded by Science Foundation Ireland. It's in partnership with the Politecnico de Torino, and there's a single student working on that at the moment. And then we have a whole range of what I call informal projects that may or may not be funded, but that's one of the nice things, that we've lots of collaborators and partners. Given the multidisciplinary nature of wave energy and marine renewable energy, there are always useful partnerships to have, because we never have the whole range of disciplines. In fact, I would probably argue that there's no one centre that has the whole range of disciplines, nor any industry or industrial company either. So partnerships, I think, in the marine renewable energy area are absolutely important. So one of the projects we have is looking at mooring co-design, where we actually use the moorings as an active part of the dynamics of the system, and it works in unison with the control system and all the other aspects of the system. Partnership with Aalborg University in Denmark and Sigma, who are an implementation company in Sweden. We have a project which is co-supervised by Damien, looking at WEC model uncertainty quantification. I mean, probably people have heard the line that all models are incorrect, but some are useful. Right? So it's important to understand what the nominal values of the model are, but also what the error in the model parameters are. And sometimes we can do something about that using robust control techniques, which Damien has been heavily involved in developing. We spend a fair bit of time these days looking at joint renewable resource assessment, and particularly in Ireland, we are blessed with a big wave climate, not so much sunshine. We have some tide, and then of course there's wind, onshore wind and offshore wind. And these can complement each other, and Unfortunately, in Ireland, the sort of political interest is really in furthering. We have a lot of onshore wind deployed already, and the interest is in more offshore wind. But sometimes the wind doesn't blow, and then you have to have some backup, or you have to have a lot of storage, and that's an expensive proposition. So, if we get the right mix of renewables, then we can. It's much easier to aim for a sort of zero carbon scenario, with maybe some storage, but certainly the amount of storage you will need will be a lot less if you have a nice mix of renewables. And we're also looking at how the resource evolves, because we're going to put devices in the water for 20 or 25 years, and we can see actually from this plot here, this shows the total momentum on a device, and it's increasing slowly as the years go by. So, the device we design for today will not be the device that you would design for 20 or 25 years' time. And we need to appreciate the evolution in the resource. In fact, it's not always the case in all locations that the resource increases. In some locations, the resource is decreasing. We have a nice collaboration with the University Nacional de La Plata on wave energy control, mostly for oscillating water columns. And we're having a new project on estimation using sliding modes. Facundo, yes, is the main man there. And then, this is a nice project with one of our industry partners who are interested in our most high-performance controller, which is quite challenging to implement, but it's a very powerful controller. So they're interested in having the best controller on their device. And, if you're going to spend $1 million on a wave energy device, you might as well have a good controller because, as people say, it's only software. Okay. Now, the design effort involved in putting those controllers together is not insignificant, but in terms of the implementation and the value over the lifetime of the project, that's quite significant. Apart from our technical activities, we're here at a version of the Maynooth Wave Energy Workshop, I guess. So, this started off in 2009, and it started off as a very informal event. It's a nice way to get people from academia and industry together, and I think we've all enjoyed the interaction over the last few days. We all also have outreach programs, so we have these little demonstration tanks. This is an oscillating water column one, and then we have another one which has a point absorber and a flap in it. And these are great. I mean, the most important things, the most important thing about them is that they're interactive. So rather than the kids messing around with the devices, they generate the waves, and they're trying to generate the best waves that get the thing to move as much as possible. And everybody gets wet, much to the parents' disgust, but everyone has a bit of fun, and that's the most important thing. And if we are doing demonstration stuff, it's so important that there's some level of interaction. And it's the same with this little real-time control demonstrator we have. There's a tuning knob that you can use to tune the controller so you can see what the effect is on the energy capture. We also run a seminar series, and this has been running for over 10 years. We've always streamed it. I mean, the tools for streaming and stuff certainly improved during COVID, but even before that, we were streaming it. And, a lot of our collaborators and even sort of various other people tune in on a Thursday morning at 11 o'clock Irish time. So at the moment, that's 8 a.m. In Chile, in fact, and it's 3 hours difference at the moment. Is that right? Between Ireland and Chile, and also with Argentina. Sorry? And you've 3, yeah. So, 8 a.m. is not a big stretch. I think when the clocks change, maybe it's tougher, is it? But Damien is certainly a loyal follower of our seminar series, and a lot of other people. I mean, the only difficulty, and we were talking about, virtual conferences, is the difference in time zones. But if you can get over that, you're more than welcome to join in either as a person in the audience or indeed a presenter. And one of the nice things about having, we usually have about 25 people or something like that in the room. But then we usually have, somewhere between 10 and 20 people online, sometimes from as many as 12 countries. And some of them, they tough out the time difference and get up early or late as it is. So if you're interested in joining, please do. The more people, the better. And if you just email Carrie Ann Barry or email me, we'll get you on the mailing list for announcements. And then you can decide if there's one that's of particular interest to you, you can join in. Or if you'd like to give a seminar, we'd be delighted as well. The seminars are very informal. I mean, they're, maybe as little as 15 minutes of presentation, but up to 45. And then the best part of it is just the discussion, and that's where people get information from the seminar, but also give information into the seminar. And it's a very interactive thing. And actually, one of the most important parts of our seminar series is we have cake at the end of it, right? But that's only for the people who are physically in the room, unfortunately. During COVID, we had this virtual cake thing, but of course, that was a bit of a disaster, as you can imagine. But anyway, it's every Thursday morning, hail, rain or snow, at 11 o'clock Irish time. And so at the moment, we're recruiting on a few projects. So if there's any people or you're interested in doing a PhD project, we have 3 PhD positions on two on the Sea Change project, which are looking at 2 different aspects. One is a control co-design, looking on the mooring side of things, particularly, and also looking at actuated geometry. One of the real difficulties for wave energy, unlike a wind turbine, where you can spill power by just pitching the blades or yawing the turbine, it's very hard to spill power in a wave energy device. So with actuated geometry, we're looking at how we might change the configuration of the device to reduce the impact of the waves on the device when the wave power gets quite high. And then, as I mentioned before, we have a new project starting on cyclorotor control, so we're recruiting a PhD student on that. And then there are also PhD scholarships and Marie Curie. We've had great success with Marie Curie, both incoming and outgoing. In fact, in 1 year, I think we had 4 outgoing that were successful, 4 out of 4, and 1 coming in. And the success rate, Europe-wide for Marie Curie is somewhere around 10 to 12%. So we certainly seem to have hit the sweet spot in terms of getting people involved in that. And then we have a bunch of funding applications, so we anticipate a lot more postdoc and PhD positions in the near future. And finally, this is more for students in the audience, but and this is a caricature that was made by one of our students when I was head of department. That's how I got the crown on here, And my caricature is not so bad, but some of the other staff didn't fare so well, But I guess the point is that, I was never determined to be an engineer, for example. I mean, when I left school, I wasn't really interested in school in anything, to be honest. I was more interested in meeting my pals to play soccer, or football, as we call it here. And I wasn't particularly good at football either, but it was a lot more interesting than school. So I sort of scraped through school, and then myself and my best friend, we convinced each other that we should join the Merchant Navy. Right? So we both applied to the Merchant Navy. This wasn't too well thought out, I can tell you. And my friend got it. So he went off, and he spent 2.5 years in the Merchant Navy, and then he couldn't stick it. I mean, we both had, completely crazy illusions about what it was or what it wasn't. And then he joined the police force. In the meantime, I think my mother had put an application in, God bless her, to an engineering college. So I ended up going to engineering college almost by default. And then, I arrived in college, and then I thought, well, this is just more school. It's not great. So I failed all my semester 1 exams. And then I just got a bit scared about what I was going to do if I didn't pass my exams in the next semester. So I did pass my exams in the next semester. And then I trundled through 2nd year, and then 3rd year, I just got interested in the whole thing. And it was a real surprise to myself, And I think one of the messages here is that, sometimes you find yourself in scenarios that, surprise you in terms of how you react to them. And then, you know, in final year, I discovered actually I had a bit of an aptitude for it, and I did quite well in final year. And I went and did a PhD, even though I have no idea what a PhD was. And then I took an academic job because I wanted to keep doing research, because I found that I was really interested in doing new things. But of course, what came with that was teaching, right? And I didn't want to be a teacher, or at least I had convinced myself I didn't want to be a teacher. And the first few classes were pretty scary, both for me and for the students, I think, you know. They were pretty fast-paced, so nobody asked a question. But I sort of settled into it, and then I discovered I actually enjoyed teaching, and then I discovered I actually had a bit of an aptitude for that as well. So what I would say is that, you know, and now, you know, we are where we are, but it's all been a little bit accidental in my own case. And one of the things that I always, every day I'm surprised at is how, you know, I discover new things about myself that I didn't have imagined when I was at school. So what I would say to, you know, particularly for the students here, be prepared to take a few risks, and certainly you'll find some interesting things out about yourself. And that's it. Thanks for your attention.
Thank you very much, John, for the presentation. Do you have some questions?
John, very nice presentation, actually. I was wondering, maybe you can tell a little bit about the beginning of your career turning into a wave energy person, because as you mentioned before, you came from the electronic engineering and control systems, and even with biomed applications, and then sometimes you moved to wave energy. That was because of a transition in the country, or maybe because someone came up with an idea. So a little bit.
Yeah, it's a good question, and I'll keep the story very short. Yeah, so my PhD was in control engineering, and you know, I kept following different control applications for a number of years in all sorts of areas, probably 20 different application areas. And then shortly after I moved to Maynooth, a guy called in one day who had just finished his degree in UCD, which is another university in Dublin, and he lived close by, and he popped in and he said, do you have any interesting PhD projects? So I described all the wonderful projects that I was involved with, but he wasn't very enthusiastic. And he said, can I propose my own project? And I said, well, yeah, but, you know, we'll have to try and find funding for you. So he came back 2 weeks later and he said, there's a guy down the road who is looking for a controller for a wave energy device. And I asked him, well, what's a wave energy device? And that was in 2001. So basically, we did get funding. That guy down the road was a consulting engineer that worked for an Irish wave energy company. And that's where we started off. That was the hinge barge, so working on, developing potable water. And we worked with them for a number of years, and then we had more partnerships. And then, very importantly, we managed to attract a postdoc from École Centrale de Nantes. And École Centrale de Nantes has a real expertise in hydrodynamics, which I knew absolutely nothing about. And this was absolutely key in bringing another discipline or another piece of the puzzle together, you know. And basically just things took off from there. I mean, one of the important things, again, was having somebody from Nantes who had other connections. And that's how the Wave Energy Workshop started, because the guy from Nantes was Jean-Christophe Gilletot. And he maintained links with ECN, and then he got some funding from the French government for this exchange, which turned into the Wave Energy Workshop, you know. So it was all quite accidental. And generally speaking, I've never spent more than probably 4 or 5 years in any particular control application. I just love the variety, you know. Some people stick with one application for their life, but I just get bored. And I worked in time series modeling for about 12 years, and then I decided to chuck that at the end of it, and I did something else. But wave energy is certainly just continues to entertain, you know. There are so many challenges there. You know, it's a very, I guess, honourable application to look at, and very important from a societal point of view. And there's fantastic, you know, I've met fantastic people, including many of the people here, you know. And that's one of the things that keeps me enthused to stick with wave energy. So I hope that answers your question.
Thank you very much, Ringwood. Professor Ringwood. Any other question? No? Okay, so thanks again.